Hey everyone, welcome to another BTM screencast. Today we're going over Chapter 7 in the Facilities Maintenance textbook for Carpentry. So by the end of this chapter, these are a few things that you'll be able to do. So you should be able to describe the general properties of hardwood and softwood commonly used by facilities maintenance techs, which would be you one day. Describe the effects of moisture content on different wood products. Perform estimating and takeoff quantities for simple one-step carpentry projects, which you should be pretty good at that by now. Correctly identify and select engineered products, panels, and sheet goods. Correctly identify framing components, which again, you should be pretty good at that by now. Perform interior carpentry maintenance and perform exterior carpentry maintenance. So some of the tools that you'll use, we use some portable fastening tools. So in this one, they're using a pass load. We do not have a pass load, but we do have a battery operated nail gun, which you will be able to use at some point. So the two that they're talking about are pneumatic. So the pneumatic, those are powered by air. We do have air lines in the lab, however, we don't have any pneumatic nail guns. The power actuated, this is what the pass load are. Um, that should be powder, but on this one, there's like a charge and it just drives it in, and you can actually set nails into steel and stuff like that. So there's two different classifications of wood, hardwood and softwood. So hardwood comes from deciduous trees that shed their leaves every year. So if you look, that's like maple or oak, things like that. And softwood comes from coniferous or cone-bearing trees, commonly known as evergreens. So I'm sure you've seen some of these too, like pine trees, fir trees, uh, things along those lines. And here's a couple examples of each one and how they look. So you can look at this in more detail on your own time. Those are some of the hardwoods. And some of the softwoods are right here. Again, if you're more interested in those, feel free to do further research. So, what are the effects of moisture content? Lumber, when it's first cut from the log, is called green lumber. It's green because it's wet, it's new, it's fresh. A piece 2 inches thick, 6 inches wide, and 10 feet long may contain as much as 4.5 gallons of water, which is a lot if you think about it. I mean, that's 4 jugs of water sitting there. Green lumber should not be used in construction. And this is a good point, right? You don't want to use green lumber in construction just because of the amount of moisture that it has and the amount that it can shrink. So to correctly identify and select engineered products, panels, and sheet goods, so let's talk about engineered panels. Engineered panels are human-made products in the form of large reconstituted wood sheets, sometimes called panels or boards. These we've used, and here's some examples of plywood. You guys have used that in the lab, and you'll be using it again. And also OSB. This is what you used on the floors for your booth construction, or oriented strand board. So those are just like, they look like chips. They're taken, they're pressed and glued together, and that's what we use. Some of the non-structural panels are hardwood plywood, so you can get that with the veneers, which is a very, very thin coating of the plywood. The most popular are birch, oak, and luan. Particle board is reconstituted wood panels made of wood flakes, chips, sawdust, and planer shavings. We won't be using this, so don't worry about that too much. The fiber boards manufactures high density, medium density, and low density boards. So you'll usually hear this as HDF or MDF. These two are pretty commonly used. Hardboards, high density fiber boards, sometimes known by the trademark Masonite. This is pretty common. Again, do more research into it if you're interested, but for all intents and purposes in this class, you don't need to be too familiar with it. Gypsum board, so this you will be doing this here. So gypsum board is also known as drywall, and that's what we have this individual finishing here. And there's also plastic laminates. So sometimes you'll see these on kitchen countertops. They're in a variety of designs. They're easy to use, easy to clean, and they're a cheaper alternative to granite or engineered stone or stone countertops. So when you're installing drywall, as they are here, you can select different drywall thicknesses and residential and commercial. So you can have 1/4 inch drywall, you can have half-inch drywall, and you can have 5/8. These three by far are the most common, and you'll see these. In the lab, we're going to be using mainly half-inch drywall. Drywall fasteners, so you can use nails or you can use screws. In the lab, we will be using screws, and because we're using half-inch drywall, we're using inch and 5/8 screws. So depending on where your drywall is, there will be a fastener schedule. So we went through this in previous classes, but the fastener schedules let you know the location, the type of fastener that you're going to be using, who's going to be using it, how far apart they're going to be, and all of that changes depending on the thickness of the drywall, where it's going to be hung, and the type of fastener that you're using. When it comes to estimating drywall materials, so this is going to be similar to the estimations that you did last year using the plywood. So what you're going to do is figure out the area, right? That's one way to start. So your length times width, and depending on the size of the drywall in the lab, we're going to be using 4x8 sheets. So you divide that by 32. So if we do this, it'll give us a rough idea of how many sheets of drywall that we'll need. To determine the number of fasteners, so you go around the perimeter, right? Let's say this is one wall, and you'll be able to figure out how many sheets of drywall that you have, and then how many fasteners for each sheet of drywall. Determining the amount of drywall tape. So again, you're going to have to figure out the amount of sheets that you're going to need, and then you'll be able to figure out the amount of tape for corners and for joints. We'll be covering this more in lab, so don't get too excited about it right now. It'll be easier when we do the application of it. Determining the amount of drywall compound. This one, we're not going to worry about estimating. This is if you're getting into it pretty hardcore. So if you're going to install a single layer of drywall, always plan the layout, right? And that's why you guys always do a drawing first to get an idea of the wall, the centers of your studs, the locations of them. When you're installing drywall on a ceiling, there's a few ways to do this. We will cover it in lab. This is why you will be working in teams. If you're installing drywall on a wall, again, it's easier if you do it in teams, and we're going to be going over that in lab. Installing drywall on a curved surface, we will not be covering that in lab, but if you're interested in learning how to do it, let me know, and we'll be able to discuss it on an individual basis. A multi-layer application, so this is common sometimes too. Um, if you want to do more than one layer, so going back to the curved one, a lot of times this is done in multiple layers, so then you could use a thinner drywall and it's a lot easier to bend than what a thicker sheet of drywall is. But again, don't get too caught up on this. It's nothing that will get into great detail unless you want to. Installing drywall and steel studs, some of you will get to this, some of you won't. In this instance, we will be using 1¼ self-tapping drywall screws. These are different than the ones that we'd use going into wood studs. The wood studs are coarse thread, 1 5/8. And on steel studs, also known as metal studs, they are fine threads of 1 1/4. We have both, so keep that in mind. If you want to make a steel stud wall, metal stud wall, and install drywall, let me know. And again, that's something that you can do on an individual basis. On this, don't get too caught up on this. We will be installing it to code, and I will give you the latest code specifications to install the drywall depending on the size, the center of the studs, and everything else. Sound waves. So sound is a type of energy that is created by vibrations. You're hearing it right now. When an object vibrates, it causes the air particles to vibrate or move. The study of sound, its production, transmission, and effects is called acoustics. A lot of times what you'll have is an acoustical analysis for a room. If you think of a movie theater, if you look up at the walls, there's like those big things hanging on the walls. Those are help deaden the sound so it doesn't echo throughout the room. So we're going to get into more detail about controlling sound and acoustical insulation. So don't worry too much about this. On this one, we can talk about this one. We can talk about this one. We won't. And this one we can talk about. So on wall construction, if you go into the theory room, that was a BTM project a few years ago, and there's acoustical batting put on the inside. And it's a special type of insulation that will actually help deaden the sound going in between rooms. There's also different materials that we could use. Again, if you want to get into this more, we'll do it on an individual basis. The floor and ceiling construction, the ceiling can go into this. Again, if you look into the theory room, those are acoustical panels that are in the ceiling, and those help prevent sound. Instead of bouncing it back and forth, like the floor or one of the masonry walls, it'll help absorb it and deaden the echo so it sounds a little better in there. Framing components, you should be familiar with this. So plates, where at the top and bottom, horizontal members of a wall frame. So we have the bottom plate, top plate, and then double top plate, if you remember. So if this is our wall, here's our bottom plate, studs, first top plate, and there's our second or double top plate. Studs are the vertical members of the wall frame. Headers, which you'll be getting more into this year, run vertical to the studs, and we'll get more into this when you're ready to do your window and door framing. This piece right here is your header. Rough sills, they form the bottom of a window opening at right angles to the studs. Again, we'll get into this in more detail. Trimmers or jack studs are shortened studs that support the headers. So before we had this, right? So if we have these studs can run all the way up. Those can be your king studs. Your trimmer or your jack studs go right here. So that's a jack, that's a jack. Here's your header, king stud, king stud. Corner posts that are same length as studs. We'll get into this because it depends on the type of corner that you're going to build. There's a few different ones that we do. Partition intersections. So again, some of you did this last year. We'll get into more detail. Ribbons are horizontal members of the exterior wall in balloon construction. Balloon construction is important to know, but it's something that we will not be doing. Balloon construction, you have a stud that goes from, let's say you've a two-story house. It goes from your first floor up to your second floor, and here would be your ribbon, and that's how you detach your joists, compared to platform framing where we do a wall, then a platform, and then a wall on top of it. Corner braces, they're used to brace walls, so we do some of this in lab, and you guys should be familiar with that. We also do rack braces until we get the sheathing hung. So here's some images of the framing components. So here we go again. Here's the rough sill, that's what they talked about for your windows. These are your cripple studs. Those are cut in to meet your sill, and they go from your header to your plate. This is your sole plate, which goes on top of your wall, or if it's on your, sorry, it'll go on top of your floor, that goes on top of your wall. This is the king stud, it runs all the way up. This is your trimmer stud here. Here's your header, first top plate, second top plate. So you can see that the door and the window construction is similar. The difference is here we don't have our rough sill and we don't have the cripple studs on the bottom. This header runs all the way up to the top. Sometimes they do, sometimes they don't. This one runs all the way up to the top. So again, we eliminated the cripple studs that were over here on the window one. Steel framing. Um, this is beyond the scope of this class. So if it's something that you want to get into, again, on an individual basis, let me know. Trusses. Um, again, these are pre-manufactured. You just order them according to specification. They're installed. And this saves a lot of time for you for roof framing, so you don't need to cut uh, any of your rafters. The trusses do it. So it's an assembly of structural members joined to form a rigid framework. There's a lot of different types of truss construction. All of them have a different application. All of them have different types of spans. All of them take different types of loads. One thing to keep in mind when using a truss is typically attic space is lost. So if you're planning on using the attic as more than just storage or to run like HVAC components and stuff like that, think about if running trusses is advantageous versus framing it out and having rafters. A cricket or a drainage diverter. So this, you'll see it's usually if there's a chimney there. So if this is your roof and you have a chimney here, typically your cricket would run like this and then help divert water away from it. Estimating construction materials, you guys should be pretty proficient at this. So we do use a bunch of techniques. There's computer programs, but we don't use those in BTM. We don't get too involved with the estimation portion of it. There's websites and also local building material suppliers. So they will work with you if you have a project and you can bring them in prints. A lot of times they'll do a takeoff because they have the software and they have the experts that'll do it. Interior doors. So when you're repairing and replacing interior doors, always keep these things in mind. A lot of this sounds complicated with what they're doing and what they're showing here, but this is something that we'll be doing in lab, and it's a lot easier than what it looks, right? As soon as you get the hang of it and you have some basic principles down, you'll be able to do this no problem. So in summary, two classifications of wood are hardwood and softwood. Hardwood comes from deciduous trees that shed their leaves each year. Softwood comes from coniferous or cone-bearing trees, commonly known as evergreens. Lumber, when it's first cut from the log, is called green lumber. And remember, a piece that's 2 inches thick, 6 inches wide, and 10 feet long may contain up to 4¼ gallons of water. So think about this. This is about the size of the 2x6s that we have in the lab. Green lumber should not be used in construction. Engineered panels are human-made products in the form of large, reconstituted wood sheets, sometimes called panels or boards. Plywood is one of the most extensively used engineered panels. OSB is a non-veneer performance-rated structural panel composed of small, oriented, or lined-up, strand-like wood pieces arranged in 3 to 5 layers, with each layer at right angles to each other. Again, this is what you use on the floors of your booths. Hardwood plywood is available with hardwood face veneers, of which the most popular are birch, oak, and luan. Particle board, which we covered, is reconstituted wood panels made of wood flakes, chips, sawdust, and planer shavings. Fiberboards are manufactured as high density, medium density, and low density boards. Hardboards are high density fiberboards. They're sometimes known by the trademark Masonite. Gypsum board is used extensively in construction. Again, this is our drywall. And that's it. If you have any questions, feel free to ask, and I'll see you next time.